So it turns out that if you free fall, if you jump off of a cliff, you don't have to draw this. I'm just having a good time right here. If you jump off the cliff, you have a parachute, obviously, because we're not going to be morbid in this class. If you jump off of a cliff, you will experience some acceleration due to gravity, and that acceleration is going to be negative 9.8. Little g. Little g is always negative 9.8 on Earth. Yep.
Can this be our next field trip? Base jumping?
I don't think we could afford that sort of insurance.
So we gotta have insurance.
And if you throw a feather off of the cliff too, the feather will experience the same acceleration. It will be negative 9.8 meters per second squared. So you've probably all seen the bowling ball and the feather drop experiment in a vacuum. It's sort of a classic demonstration. They fall at the same speed. You take a bowling ball and a feather and you drop them both in a vacuum, then they will hit the ground at the same exact time. That's how it is in outer space too, because outer space is a vacuum. It doesn't happen here in this very, very small area that we can habitate because we have air. But almost everywhere else in the universe there's no air, so things follow the laws of physics more smoothly. So in this class we're going to assume that there is no air resistance. We're going to assume that a bowling ball and a feather will both experience the same acceleration. So when we get into our word problems with free fall, we're going to use our same three physics formulae that we have up there. It's kind of hard to see with the lights off, but I'll have them up here for you. So I got some practice problems. For example, a construction worker accidentally drops a brick from a high scaffold. What is the velocity of the brick after 4 seconds? And how far does it travel during this time? Well, we can find the velocity by using our good old velocity equation. Let's use this one. Let's use VF equals VI plus AT. We're solving for VF here. If we're dropping the brick, then our VI equals 0. Our acceleration is negative 9.8 meters per second squared. And that's all we know. Oh, I'm sorry. We have a time. Time is equal to 4 seconds. And the question is, what is the VF? So let's plug it in using this equation here. The VF is going to be equal to 0 plus negative 9.8 times 4. So you get your final velocity of negative 39.2 meters per second. Alright. Oh, you know what? We didn't do the second part, did we?
Nope.
How far does it travel during this time? So now we already have our VF. Let me write that again for you. And we still have our VI, which was 0 because we're dropping it. We still have our acceleration, which is negative 9.8 meters per second squared. So in order to figure out the distance, we need some sort of formula with a d in it. And so let's use the VF squared equation. Equation is going to be VF squared equals VI squared plus 2AD. So if we plug it in up here, we have 39.2 squared. Sorry, it's kind of sloppy. Equals the velocity initial square, which is just 0, plus 2AD. So you have 2 times negative 9.8 times your D. Solve for D, and you get 78.4 meters. Now you could use this equation. You could use the distance final is equal to distance initial plus VT plus 1/2 AT squared. It's just as easy. It's one step, and you would get the exact same answer. How about this one? A student drops a ball from a window at 3.5 meters above the sidewalk. How fast is it moving when it hits the sidewalk? Well, they're giving us a D here. Our given D is 3.5 meters. Our acceleration due to gravity is always negative 9.8 meters per second squared. If we're dropping it, then our VI is 0. It's asking how fast it's moving when it hits the sidewalk. That's the final velocity. So they're asking for VF here. So let's use our VF squared formula. VF squared is going to be equal to 0 because there's no initial velocity if you're just dropping it, plus 2 times acceleration, negative 9.8, times your distance, which is 3.5 meters. If you solve it, your final velocity when the brick hits the ground is going to be 8.28 meters per second. Don't forget to take the square root when you're solving for VF using this equation. It's a very, very common mistake. How about this one? Tennis ball is thrown straight up with an initial speed of 22.5 meters per second. So now we're not dropping it, we're throwing it up. So we have a VI. Our initial velocity is 22.5 meters per second in the positive direction. It's caught the same distance above the ground. How high does the ball rise? So they're asking for a D here. What is our change in height? We know the acceleration due to gravity is going to be negative 9.8 meters per second squared. So let's use our VF squared formula. But wait a minute. What is our velocity final? It's 0, exactly. Because, remember, it's just like the rocket that went up and came back down 2 days ago. If you throw a tennis ball up, it's going to go up, and at some point it's going to stop, just for a brief moment in time. And then it's going to continue moving in the opposite direction. But for that moment in time, it's 0. So if you're trying to find how high something went, or how fast something went, and it stops at the top, don't forget that that moment in time, the velocity is 0. So we can use 0 as our VI to solve this question. VF. Thank you. So 0 equals 22.5 squared plus 2 times negative 9.8 times our D. We can solve for D and we get 25.8 meters. The next question is, how long does the ball remain in the air? So they're asking for a T for the same question. So we're going to have to use some sort of formula with a T in it. We already found the D just now. That was 25.8 meters. Our acceleration is still the same, negative 9.8 meters per second squared. So we got to pick an equation that has a T in it. Let's use the VF equals VI plus AT. Let me rewrite the velocities. Our velocity final is 0 because we're going to just solve for when it stops for that brief moment in time before it falls back down. And our velocity initial is given. So you plug it in, 0 equals 22.5 plus negative 9.8 times t. You get your t, but if you just solve this equation right here for t, you're only going to get half of the time. You're going to get 2.3 seconds. But it's going to come back down, just as William said. So you have to multiply by 2 to get the time for your total flight. So the answer to the question would be 4.6 seconds. Any questions? We're just using the same principles that we've been doing the past few days, but applying it to the vertical direction. Let's try this one with your partner, see if you can figure it out.